Hi guys, today I'm going to discuss the modified version of knapsack problem. The basic knapsack problem was here. Now let me show you what the difference is having. So the values of the items that the knapsack could hold were ranging from 1 to 1e9, and the maximum capacity of the bag was 1e5 till 1e5. But in the knapsack, modified knapsack, the you can see that the maximum value could reach up to 10 raised to the power 9, and the values are pretty less, till 10 raised to the power 3 only. So here our basic knapsack could not work because you know that in the basic knapsack version, what we made that we stored the weight from 0 to 1e5, or that is the maximum knapsack capacity. Okay, so here it's still 1e9, so I can't make an array till 1e9. So this logic is definitely flawed. So we need to modify something, and this 10 raised to the power 3 gives us hints also that we need to consider something with these values and this n. So the maximum item values that can reach is 100 into 10 raised to the power 3. Because suppose each value of the item that is given to us is 1000 only. So the maximum profit that we can get from the knapsack is R5. So basically that logic only would I would be using here. So what so now moving on to the problem statement, you would be given n items with values of each item and weights of each item. So for explanation of this problem, I would consider a very vague scenario. So basically, you had a competition yesterday where you had to run from point A to point B, and you were also, and the condition imposed was that you had a 500 rupees note, and you have to reach point A to point B with some weights on these notes, and the condition was that these notes should not tear up. So basically, what you could easily think is that the only those person will win that would have minimum weights on these notes, as then only the probability of getting the notes tiered up would be very less. So basically, this logic I would be only using here. So let me tell you what I'm trying to say. Okay, yeah. So now my DP would look like something sort of this. DPIJ, where this would represent till ith item and jth price. What is the minimum weight I could handle? What is minimum weight I could handle? So basically, I would iterate over all the values from 0 to max, or rather, sum of all values for basic optimization. Sum of all values that I would be getting from here. So now let me show you what I'm trying to say. Is like now I suppose I made a table like this where the rows represents the item numbers and so on till n. And here this column would represent my values 0, 1, 2 till sum of all values. And suppose I get to some column and to some row. Suppose I state this cell as 3, 4. So this would tell after considering the first three elements, and the value of the note in the competition that I got was 4 rupees. What is the minimum weight I could put on this note? This is the condition. So now let me take some more examples. Now suppose this was 131 and this is 9. So 9 comma 131 would tell me after considering first 9 elements and the note value was 131 rupees, what is the minimum weight that I could put on this note and win the race? So basically this is what I need to calculate also. So it so in the knapsack, to generate the maximum value, you need to put all those elements which are having minimum weight so that you could get a huge amount of items and hence make maximum profit in the reverse logic what I'm trying to explain. Basically, this is the only thing in this problem, and after this, you would just check, you would just iterate in the nth item in the nth row, and would check all the cells here is that which cell is having the weight, which cell is having the weight which is corresponding to the knapsack capacity. Okay, so now let me show you the code. It would be more clearer by that. Let me zoom also a little bit. Okay. Yeah, so here this is main function, this is so just basic template part. So here I'm assigning WNDP array, and this I'm taking as 1 till 1e5 because what I have initially told you is that it was this only. 1 second, sorry. Yeah, so basically the maximum number value of any item was 10 raised to the power 3, and there were maximum 100 elements, so the maximum value array can go up till 1e5, and till 1e7 array is completely uh, available in globally declaration. So yeah, let me move further. Okay, so here I'm this is just the basic input, and here, yeah, I need to tell you the initialization part also. It was bit thick. Okay, so now let me make the table again. 0 till n and 0 till all the values. Now, when you let me start with value. Now, suppose you have to make zero value. Suppose you don't have any node in the competition. Then you are already out of the competition. There is no competition because you don't have any node also. So all the weights 0, 0, 0, 0, 0, 0, 0. And now, suppose you don't have any item. You don't have any weight. So now speaking in terms of knapsack capacity, to generate all the values when you don't have any item, you need infinite weight. Infinity, 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 infinity. This is basically just a base case, or what you could say as that a garbage value type of thing, because when you don't have any value, how can you, because when you don't have any weight, how could you make any value? So to actually make these values, you need infinite amount of weights. So that is what I'm doing here. So let me zoom it a little bit. Yeah. So here I am assigning that infinity part. Here I am assigning that zero part, and here is the basic what I have said to you today. Okay. So basically, I would be iterating over all the n, and this is the I am iterating over all the sum. This is I'm calculating this here. So if the value of the item, okay, now I need to explain this also. Just 1 second. Now suppose you get these values, and suppose you consider this element, and you had a 5 rupees note only, but it's saying that this weight can land only upon note of value 10, or rather you could say that its size is so big that it can be fitted only in a $10 or a greater note. So it is definite that we can't put this weight on this note. Hence, I would certainly reject this, and that is what I'm doing here. Okay. So if the value is greater than the current node considered, then considering this element, the answer for this state would be only considering the previous element and what is the total weight I have gathered till the previous element. And otherwise, if the value of the item is less than the node I am having, I would be just choosing the minimum of if I consider that weight. And if I am considering that weight, then I would just uh, go to the previous version as I have already considered that. Otherwise, I am not considering it. It's just that basically that finding that part of the weight which is just smaller or equal to the knapsack weight given. And if that would be the condition, as the values are represented by columns, so just I would output that column number. And let me run a test case also so that you get assured of that it's working fine. Okay, let me take a good case. Yeah, this one is fine. Sorry, copy or it's running. Just 1 second. Come on. Yeah. So the answer we got is 117. The time here it's showing not actual. It can't be just 22 seconds here. So I think I have explained it thoroughly, and if you need any clarification further on this, you could comment down below, and I would definitely answer that. Thank you.